I'm Jack Norris. This is my project, SME, or Open Source Medical Equipment. It's a range of medical diagnosis equipment made open source for professionals around the world to access. In more developing parts of the world, horrible diseases such as scabies affect hundreds of millions of people a year, and there are many others as well. Like most diseases, if they're caught early through diagnosis, they're much more treatable. Leprosy, for example, has a completely free cure from the World Health Organization. However, diagnosis using these sort of diagnosis tools is holding people back from the treatment they need. Here I have a phone-mounted dermatoscope as well as a handheld dermatoscope, both used for looking at skin lesions and skin health, as well as an otoscope for looking into ears and ear health. An off-the-shelf dermatoscope could easily cost £1,000, if not more. Per individual, the UK spends £4,200 on healthcare for everyone in the country. In places like Nigeria, it's £30. In other places, even less. And that's true for lots of other medical devices as well, making them inaccessible to doctors and nurses all around the world. So to fix that, I've been working with doctors here in the UK to create open source medical equipment any professional can put together themselves.
Yeah, okay, so I'm Daniel Keith. I'm a consultant dermatologist here at Southmead Hospital in Bristol. I have special interests in skin cancer, diagnosis, skin cancer surgery, and laser medicine. I've been a consultant here since 2017, and I've been working in the southwest of England since 2013 in dermatology. So the idea of 3D printing a dermatoscope has been something which has been of interest to us, because the parts we've been recommending before aren't necessarily things that have been very widely available, yet it seems 3D printing is becoming very widely available all over the world, in every country, and so it gives people another option for producing their own dermatoscope at a low cost, so we'd hope that we can produce this and then allow people to use it for free forever, for as long as it's helpful for people to use it to help with skin diagnosis. I think we've been very impressed with how quickly you've been able to come up with these ideas, and actually it's been very nice to work with someone who doesn't have a preconceived idea of what a dermatoscope should be. For us to be able to just tell you what we want it to be able to do,
Functions of it.
and for you to come up with the idea, it's been very impressive. And very helpful. So our contact in Egypt told us there's one dermatoscope for the whole hospital that she's in, and that's a major public teaching hospital in a capital city.
Do you mean the cost of the dermatoscope?
The cost is there, yeah. So the cost is prohibitive. The companies that sell them know that, so they don't really have a big presence in those countries because the sales are low. But increasingly, dermoscopy is being used for inflammatory and infectious dermatology as well. So you're finding, instead of expensive biopsying of patients, and it's an invasive procedure to cut out a piece of a patient to find out what something is, dermoscopy is being used to diagnose rashes, infectious disease, which are of course very common all over the world, and have a big impact. So if you can start to diagnose those closer to where patients are, that would be of equal value to them. And now it's pretty much mandatory in every clinic to have a dermatoscope. In a skin lesion clinic, you'd be expected to examine every patient with a dermatoscope because it gives you so much extra information. So we've previously published on our other projects, and we'd hope to do a similar sort of project with this. So the aim at the moment, now that we're at or close to having a final product, is to start taking photographs of common lesions with conventional dermatoscopes and these devices, as particularly the one designed specifically for taking photographs, and compare them side by side. So photographs of the same lesion, same diagnosis, taken with both devices, and our plan will be to get physicians to have a look at these images and rate their confidence in diagnosis on one and then the other, and see whether there's a significant difference between them, and see whether it adds to the diagnostic confidence compared to just looking at it with the naked eye. And then after that, we'd be looking to write this up to disseminate it as a journal article. We'd also hope to be able to put all of this information out on the Dermoscopia website, which is a growing resource, to enable as many people to access it around the world as possible.
All the components in the devices are made from off-the-shelf things like this jewelry magnifier, or custom components are 3D printed. Many hospitals already have FDM printers or resin printers for printing prosthetics and stuff like that, or they can access FDM parts online. The total cost for something like this comes down to around £20, or even cheaper if they build them in bulk. And everything can be put together really simply. All they need is a pair of scissors, there's no soldering or anything like that. A child can put one of these together. After speaking to so many amazing people, I just think anyone that is willing to devote their time to helping others deserves the tools to do so.